Welcome to Brain Vision.
Okay, here is our system. And we want to find this angle theta. Now, it's much easier to find this angle theta if we first find this angle, which is theta over 2. Okay, well, using some trigonometry, we can say that sine half of theta over 2, right, is going to equal 1/2 the length of an aluminum part, and then over the length of an invar part. Okay, now we know the invar part is constant the whole time, and it says in the problem that each side originally starts at 40 centimeters. Okay, but the aluminum changes, and it changes based on the expansion equation, which of course says that LF is going to be equal to the initial, which I'm just going to say is L, times 1 plus alpha aluminum delta T. And then this is going to be over L. I'm just saying L is here. L equals 40 centimeters. Okay, the L's will cancel out, and we'll get an equation sine of 1/2 theta is equal to 1 plus alpha aluminum delta T over 2. Now we can move some stuff around, do some inverse trig, and we get theta is equal to 2 sine, arc sine, or inverse sine, of 1 plus alpha aluminum delta T over 2. Okay, that's for part A. Now for part B, oh, and also as an aside, make sure you put in the correct value for alpha aluminum here, which is stated above. Okay, for part B, does this work for negative numbers? Yes, so what I would say for this is to graph our function on your calculator, Desmos, to just see how it behaves, and you will see that it looks something like this. This is going to be 60 degrees. It's going to kind of keep going up, and it might have a little squiggle to it based on the arc sine, but it's going to look like that. And yes, this is what we would expect for the negative function. It makes sense, you know, when aluminum, when temperature decreases, it shrinks, and we would expect for it to shrink, the angle would also shrink. So yep, that does make sense. Part C, what about when it's 0? Delta T equals 0. Does this make sense? Yes, because if you graph it, if you solve it, you should find that theta of 0 is equal to 60 degrees. Of course, we start with a equilateral triangle, which of course has angles of only 60 degrees. Great. Now D, now let's consider the invar changes. So let's return to our equation we had before. Sine of 1/2 theta is equal to 1/2 the length of the aluminum side over the length of the invar side. And just like before, we had expanded out our aluminum side, so we had 1/2 L times 1 plus alpha aluminum delta T. But now we also need to expand our invar side, and that's of course just going to be L times 1 plus alpha invar I delta T. Again, the L's will cancel out, and we can do some more trigonometry, move stuff around, and find that theta is going to be equal to 2 inverse sine of 1/2 times 1 plus alpha aluminum delta T over 1 plus alpha invar delta T. And if you just plug in values for alpha aluminum and alpha invar, which you can look up in your textbook, I also wrote them at the top of the question, that should solve that part. Okay, now next, what is the, I believe it is the greatest angle? Well, we know that the hotter something gets, the greater our change in temperature, the more it expands. And based on our question, we're kind of constrained to a temperature of 660 degrees Celsius, because that's when, of course, aluminum melts, and when one of them melts, the whole thing will fall apart. So I won't do the whole thing out, but with this equation, and if you put in 660 for that delta T, you should get 61.01 degrees. Similarly for F, the least, or the smallest I should say, angle is going to happen at the smallest temperature, or the most negative temperature difference we can get. Because, of course, when a temperature difference is negative, the length of an object will decrease, right? Similarly, just like part E. Now we know the smallest temperature we can get is going to be negative 273 degrees Celsius. You can expand that out a couple more digits. It would be 0.15 if you want to be extra specific. But that's just the rule. Absolute zero, that's just a physical law. So plug that into our equation from part D. And you should find that the smallest angle we will get is going to be 59.58 degrees, just about.